Today's class is on previous years asked KCET on vector algebra. First question, if A and B are mutually perpendicular unit vectors, then 3A plus 2B dot 5A minus 6B is equal to, options are 5, 3, 6, 12 asked in 2018. So find the value of this. So find do find dot product of these two vectors. 3a dot 5a, 3 into 5 15. A dot a is equal to magnitude of a square, plus into minus minus 3a dot 6b, 3 into 6 18, a dot b. Next, plus into plus plus 2b dot 5a, 2 into 5 10, b dot a equal to a dot b, because dot product is commutative. B dot a is equal to a dot b. So therefore b dot a can be written as a dot b, plus into minus minus 2 into 6 12, b dot b is equal to magnitude of b square. Here a and b are mutually perpendicular unit vectors, it is given. Therefore unit vector a and b are unit vectors, therefore magnitude of a is equal to 1, magnitude of b is equal to 1. 15 into 1 15. So here a and b are mutually perpendicular vectors, therefore a dot b becomes 0, a dot b becomes 0 here. So this minus 12 into magnitude of b is 1, 12 into 1 is 12, 15 minus 12, 3. Therefore option B is correct. Next question, if the vectors ai plus j plus k, comma I plus bj plus k and I plus j plus ck are coplanar, then the value of abc minus of a plus b plus c is equal to. So options are 2, minus 2, 0, minus 1, asked in 2018 KCET. So here given that these three vectors are coplanar. So therefore from the definition of coplanar of three vectors, determinant of, so here write the values in the determinant. So here the first vector coefficients a 1 1, so first row a 1 1, second row second vector coefficients, so 1 b 1 1 b 1, third row third vector coefficients 1 1 c 1 1 c. Determinant of this becomes 0. This is from the definition of coplanarity of three vectors. So already we know this result. Now evaluate this determinant of order 3. So a into multiply these two bc minus 1 into 1 1, next minus 1 into, so delete this row this column, 1 into cc minus 1 into 1 1 plus 1 into, delete this row this column, 1 into 1 1 minus 1 into b, b 1 minus b equal to 0. So multiply by a b c minus a, this is minus c minus it minus plus 1 plus 1 minus b equal to 0. We want the value of this ABC, here ABC is there, minus a minus b minus is there, so take minus common because we want this term, minus of a plus b plus c equal to, here 1 plus 1 2, take the right side becomes minus 2. So therefore the value of ABC minus a plus b plus c is minus 2. Therefore option B is correct. Next problem, if the angle between vector A and vector B is 2 pi by 3 and the projection of vector A in the direction of vector B is minus 2, then magnitude of A is equal to, options are 4, 2, 3, 1 asked in 2019 KCET. Here the projection of vector A in the direction of vector B is given. So that is the definition of projection of vector A in the direction of vector B is A dot B divided by magnitude of vector B. So this is projection of vector A in the direction of vector B. So it is given, the projection is -2. Okay, so it is given. So which implies the A dot B from the definition of dot product of two vectors A and B. A dot B is equal to, so magnitude of A into magnitude of B into cos theta. Definition of A dot B divided by magnitude of B. So is equal to -2. So magnitude of B gets cancelled. So magnitude of A into cos theta. Here the angle between vector A and vector B is given. Angle theta is 2 pi by 3. So cos theta is 2 pi by 3 equal to -2. Magnitude of vector A into cos 2 pi by 3 can be written as pi minus pi by 3. So this is 2 pi by 3 is 120. 120 can be written as 180 minus 60. That is 120. So is equal to -2. So magnitude of A into cos 180 minus theta. 180 minus theta lies in second quadrant. In second quadrant cos is negative. So minus cos theta. So minus cos theta. Theta is pi by 3. Minus cos of pi by 3 is equal to -2. So both side minus gets cancelled. So magnitude of A into cos pi by 3 is 1 by 2. So is 1 by 2 is equal to 2. So we want magnitude of A is equal to 2 divided by, so take 1 by 2 to right hand side denominator. So this is 2 into this 2 comes to numerator. So 2 into 2. So this is 4. Magnitude of A is equal to 4. Option A is correct. Next problem. If vector A and vector B are unit vectors and theta is the angle between vector A and vector B, then sin theta by 2 is equal to, options are given, asked in KCET 2020. So here consider vector A minus vector B magnitude whole square. So this can be written as magnitude of A square plus magnitude of B square minus 2 into magnitude of A into magnitude of B into cos theta by using the result in the vectors. So here given A and B are unit vectors, so therefore magnitude of A is equal to 1, 1 square is 1, magnitude of B is also 1, minus 2 into, again magnitude of A and B are 1, so 1 into cos theta into 2, 2 cos theta. So this is 1 plus 1, 2, 2 minus 2 cos theta, so 2 is common, so take 2 outside, we get 1 minus cos theta. So 2 into 1 minus cos theta can be written as 2 sin square theta by 2. So in the left hand side, magnitude of A minus B whole square. So 2 into 2, 4. So take this side, magnitude of A minus magnitude of B whole square divided by 4 is equal to sin square theta by 2. But we want sin theta by 2. Here sin square theta by 2 is there. So therefore, sin theta by 2 it can be written as, so here take square root to this side. So magnitude of A minus B whole square root becomes magnitude of A minus B divided by square root of 4 is 2. So therefore sin theta by 2 is equal to magnitude of A minus B divided by 2. Option B is correct. Next question. Two vectors I plus j plus k and I plus 3j plus 5k represents the two sides AB and AC respectively of triangle ABC. The length of the median through A is, options are given asked in KCET 2020. So here in triangle ABC, consider triangle ABC, and the length of the median through A is, so this is median for the side BC, so this is D, take this as D, AD is the median. So you have to find the length of the median through A, AD is the median through A, so you have to find the length of AD. Okay, so here AD is the midpoint of BC. So therefore, the side AD is the midpoint of BC and AD is the median for the side BC. So therefore, AD can be written as the sum of these two sides, I plus j plus k. So AB represents this vector, I plus j plus k, and plus AC. So AC is I plus 3j plus 5k divided by 2, because this is the median, AD is the median for these two sides. So therefore, add I plus I 2i plus j plus 3j 4j plus k plus 5k 6k divided by 2. So take 2 as common factor in the numerator, I plus 2j plus 3k divided by 2. 2 gets cancelled. So I plus 2j plus 3k. So this is side AD. This vector represents the median AD. So we have to find the length of the AD. So that is magnitude. Length means magnitude. So therefore, magnitude of AD is root 1 square 1 plus 2 square 4 plus 3 square 9. So this is root 14. So therefore, the length of the median A, that is length of AD, is root 14. Answer C is correct. Next problem. If magnitude of A cross B whole square plus magnitude of A dot B whole square is equal to 144 and magnitude of A is equal to 6, then magnitude of B is equal to, options are 3, 2, 4, 6 asked in KCET 2020. So we know that from the definition of vector product or cross product, A cross B is equal to magnitude of A into magnitude of B into sin theta, but here square is there. So therefore, magnitude of A square into magnitude of B square into sin square theta, plus next A dot B is magnitude of A into magnitude of B into sin theta into cos theta, but here square is there. So magnitude of A square into magnitude of B square into cos square theta. So this is equal to 144. Here magnitude of A square, magnitude of B square is common in both the terms. So take it as common, we get sin square theta plus cos square theta. So that is equal to 1. So therefore, this is into 1. So therefore, this is, again we get magnitude of A square into magnitude of B square is equal to 144. We want magnitude of B. So magnitude of B square is there is equal to 144 divided by magnitude of A square. Magnitude of A is given, that is 6. So magnitude of A square, 6 square, that is 36. 36 1 ja, 36 4 ja. So therefore this is 4. Magnitude of B square is equal to 4. Therefore magnitude of B is equal to square root of 4, that is 2. Therefore option B is correct. Next question. if vector A equal to 2i plus lambda j plus k and vector B equal to I plus 2j plus 3k are orthogonal vectors, then the value of lambda is options 3 by 2, 1, minus 5 by 2, 0 asked in 2017. So here A and B are orthogonal means perpendicular vectors. So therefore A dot B equal to 0. Since A and B are perpendicular or orthogonal vectors, then their dot product equal to 0. A dot B, find dot product of these two vectors, means multiply the coefficient of ijk of the vectors A and B. Here coefficient of I is 2, here 1, 2 into 1, 2 into 1 plus next here coefficient of j lambda, here 2, so lambda into 2 plus coefficient of k is 1, here 3, so 1 into 3. This is A dot B equal to 0. 2 plus 2 lambda plus 3 equal to 0. 2 lambda equal to 2 plus 3 5. So take right side becomes minus 5. So therefore lambda equal to minus 5 by 2. Option C is correct. Next problem. If magnitude of vector A is 16, magnitude of vector B is 4, then square root of magnitude of A cross B whole square plus magnitude of A dot B whole square is equal to dash. Options are 4, 16, 8, 64 asked in 2019. So here consider square root of A magnitude of A cross B whole square plus magnitude of A dot B whole square. We have to find value of this. So this is square root of definition of A cross B is equal to magnitude of A, but the square is there, magnitude of A square into magnitude of B square into sine square theta from the definition of vector product of two vectors A and B plus again A dot B, magnitude of A dot B whole square, definition of A dot B, magnitude of A into magnitude of B into cos theta, square is there, so magnitude of A square into magnitude of B square into cos square theta. So square root of, so in the two terms, magnitude of A square, magnitude of B square is common. So take outside magnitude of A square into magnitude of B square. So we get sin square theta plus cos square theta. Sin square theta plus cos square theta. So sin square theta plus cos square theta is 1. 1 into magnitude of A square into magnitude of B square, magnitude of A square into magnitude of B square, square root is there. So therefore, this is magnitude of A into magnitude of B. So values are given. Magnitude of A is 16 into magnitude of B is equal to 4. The product is 64. Therefore, option D is correct. Next problem. If vector A, B, C are unit vectors such that A plus B plus C is equal to 0 vector, then A dot B plus B dot C plus C dot A is equal to dash. Options are 3 by 2, minus 3 by 2, 2 by 3, 1 by 2, asked 2 times, 2013, 2017, KCET. So here it is given vector A plus vector B plus vector C is equal to 0 vector. So therefore take squaring on both sides. So we get A plus B plus C whole square is equal to 0. So this is A plus B plus C whole square is magnitude of A square plus magnitude of B square plus magnitude of C square plus 2 into A dot B plus B dot C plus C dot A equal to 0 square, that is 0. So since A, B, C are unit vectors, therefore magnitude of A, B, C are equal to 1. So therefore this is 1, 1 square is 1, also 1 square, 1 square, 1 square, 1 plus 1 square plus 1 square. So this is 3. So this is 2 into A dot B plus B dot C plus C dot A is equal to, so here take 3 to right side, becomes minus 3. You want A dot B plus B dot C plus C dot A. So therefore take 2 to right side denominator. So we get the value is minus 3 by 2. Option B is correct. Next problem. The area of the parallelogram whose adjacent sides are vector I plus k and vector 2i plus j plus k is, options are 3, root 2, 4 and root 3 asked in 2014 KCET. So take this as vector A and this as vector B. So find A cross B. A cross B is equal to, we know A cross B is equal to determinant of. So this is vector A, this is vector B. First row is I, J, K. Second row is components or coefficient of first vector, vector A. So coefficient of I is 1, there is no J, so therefore 0 J, coefficient is 0, 1 K, that is 1. Next, third row, coefficient of vector B, coefficient of I is 2, coefficient of J is 1, coefficient of K is 1. So this is determinant of this one. This is A cross B. So evaluate this determinant. So I into, so 0 into 1 0 minus 1 into 1 1. Next minus J into, delete this column, this row, 1 into 1 1 minus 2 into 1 2, 1 minus 2 plus K into, delete this row, this column, 1 into 1 1 minus 2 into 0 0, 1 minus 0 equal to 0 minus 1 into I minus I. This is minus 1 into minus J, minus into minus plus J. This is 1 into plus K plus K. So this is A cross B. We have to find area of parallelogram. So that is magnitude of A cross B. Area of parallelogram is magnitude of A cross B is equal to, so minus 1 whole square plus 1. So plus 1 square is 1 plus 1 square is 1. So this is root 3. So area of parallelogram, that is magnitude of A cross B is root 3. So option D is correct.